Probably were.
All right, probability with permutation and combinations. The first thing we're going to talk about is called the fundamental counting principle. Fundamental counting principle, all right? So some terms that they have thrown out here is experiment. That is a situation involving probability that you actually do. Sample space, that's the set of all possible outcomes, all right? And so then we talk about what happens with the fundamental counting principles. Let A and B be two events. If event A has n1 possible outcomes and is followed by event B that has n2 possible outcomes, then the event A followed by event B has an n1 times n2 possible outcomes. Yeah. Lots of words there, all right? What it's saying is if you put things in a progressive order and you're just trying to find out how many ways you can do this, you're basically going to multiply each option. So let's say we're making a sandwich. All right, and we have white or wheat bread. Then we have 3 types of meat and 4 toppings. All right, and you want to know how many different sandwiches you can make from that. You're going to say, well, 2 types of bread, that's 2, times 3 meats, times 4 toppings. And you would multiply all those, and that would be how many possible combinations you could get from this fundamental counting principle, okay? And so that's all it's saying is you take all of the possibilities of the first event, followed by all of the possibilities of the second event, and so on and so forth, and you just multiply them, all right? So let's look at the examples they've given us here. All right, let's look at the first one. A restaurant offers a dinner special in which a customer can select from one of 6 appetizers, a super salad, one of 12 entrees, and one of 8 desserts. How many different dinner specials are possible? Counting principle says just multiply them. My first is 6 appetizers. So I'm going to take 6 times. Then I have soup or salad. That is 2 options. Then I have 12 entrees, and then I have 8 desserts. So there are 1,152 possible different dinner combinations that I can do there. All right? That's the counting principle. Counting principle. Let's look at the next example. Garrett works for a bookstore. He is arranging the 5 bestsellers for a shelf display. If he can place the books in any order, how many different ways can he arrange them? So now we have to think about what's happening here. In the first slot of the 5 slots that we're talking about, how many books does he have to choose from? 5. All right, but now he places a book. So how many books does he have to choose from for the second slot? Yes. And so for this one, our options are based on what we are doing here. All right, and so this is 120. This is actually a special case here. 5 times 4 times 3 times 2 times 1 actually is an operation. And that operation is called factorial. Factorial. It is represented by this little exclamation point. So 5 factorial means 5 times 4 times 3 times 2 times 1. And actually in your probability formulas on your calculator, you will see an exclamation point in that little drop down that you have. That's what that means. So 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5, all the way down to 1. All right, so check your answer. It says for a particular model of car, the dealer offers 3 sizes of engine, 2 types of stereos, 18 body colors, and 7 upholstery colors. How many different possibilities are available? You should have gotten 756. 756. Okay. All right, the next thing we're going to talk about in this concept is called permutation. All right, fundamental counting principle can also be used to determine the number of ways that objects can be arranged in a certain order. An arrangement of n objects is called a permutation. The thing you want to remember when you're talking about permutation is the word order. Does order matter when I am arranging this? Usually you are taking a certain set and you are doing subsets of it. So if I said, in this classroom, we're going to have a contest and it's going to be first, second, and third. Order matters, meaning I could choose, let's say we choose this row of Alyssa, Julia, and Jules, because we have 2 Julias here. All right, and so I could actually do first, second, third, first, second, third. Like these same 3 people could be first, second, third different ways, right? And so that is a permutation. If I said I just want 3 people to help me do something, that order doesn't matter. What order I list the people in that are helping me carry books doesn't matter. That would not be a permutation, okay? So permutation is really when order matters, okay? And so the number of permutations that can happen is noted like this, and they show you this large P representing permutation, an N and an N. And so this is how many, if you had the same number of objects and how many times you can arrange it. So if I wanted all 8 of you and I wanted to do a permutation, that's just 8 factorial. It's just like the book example. If I wanted to arrange all 8 of you in a certain order, then the first place I would have 8 options. I've already placed one of you, so the second place would have 7 options. So that ends up just being that number factorial, okay? But when I have a permutations and I'm taking a subset, then it's, the way you read it is you want the permutation of n objects taken r at a time. N objects taken r at a time. And they use factorial to calculate this. N factorial, that's the total number of objects over the difference between those. The difference between the number of objects and the number that is in the group that you're taking it of. And that factorial. If you have a graphing calculator like an 83 or an 84, you can go into your probability menu and this permutation is one of your options, okay? And so you can either calculate it using your factorial if you want to, or you can just use it with the permutation. In your calculator, you're going to choose the first number, the total number that you have. Then you're going to choose permutation. Then you're going to put in the second number, the subset that you're taking it at a time. So let's look at an example of this so we can see what it's asking for. An alarm system requires a 7-digit code using the digits 0 through 9. Each digit may be used only once, all right? Only once. So I have how many digits possible? Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 digits possible. That is my total. So in this one, that's going to be the first number that I have here. I have 10 digits. And how many digits am I taking at a time? Well, that's how big my code is. That is 7. And so this is going to be 10 factorial over 10 minus 7 factorial. So that's going to be this guy right here. All over 10 minus 7 is 3 factorial, which is 2, 1. All right? That's what that formula tells me. And when you calculate it, you get a ginormous number here. That's how many different codes you can have for that alarm system. That's a lot, by the way. So the next example here, it says, if a code is randomly generated, what is the probability that the first 3 are odd? So now we're going back to the term probability, all right? Probability means what I want over total possible, okay? What I want over total possible. We just found the total possible, didn't we? Yeah. What was the total possible? The total possible was this ginormous number here, 604, 800. That's my total possible. So now we want to determine the first 3 digits are odd. The first 3 digits are odd. All right. So how many of those digits? So I have 7 digits altogether. The first 3 are odd. Okay. The first 3. So I know I'm taking 3 at a time. I know that's my second number. Of those 0 to 9, how many of those digits are odd? Yes, 5 of them are odd, right? 1, 3, 5, 7, and 9. Okay. So I only have 5 numbers to choose from if I'm saying the odd numbers. And I only want 3 of them because they said the first 3 numbers are odd, right? Now, in the counting method, that's my first 3. How many digits do I have left? It's total 7 digits, right? I've already accounted for my first 3. How many do I have left? 4. All right, now, so I know I'm going to take 4, but how many numbers do I have to choose from? I've already taken 3 of them out, haven't I?
4.
I've taken 3 of them out. I had 10 to begin with. How many digits do I have to choose from since they can't be repeated? I have 7. All right. So this one is a little bit different. This one says the first 3 are odd. So now you have to look at your pool of odd numbers. That's 5. I only want 3 of them. All right. 5 objects taken 3 at a time. Permutation. Okay. The last part of my code here is 4 digits left. So I know I'm going to take 4 out of how many? Well, I already picked 3 of them. They can't be repeated. I had 10 to choose from, so I only have 7 in this pool of numbers now. I've already taken 3 of them out. All right, so this now is my numerator. This is my numerator. When you do those permutations, you actually get this ginormous number here. They want the probability. So this ends up being about 8%. About an 8% probability. It's 0.08. About an 8% probability that the first three are odd. The first three are odd. All right, so for this one, permutation of five things taken 3 at a time was 60. 5 things taken 3 at a time is 60. The last thing we're going to look at is combination. For combination, order does not matter. So in my example where I said first, second, and third, order matters. If I said I need 3 people to help me, order does not matter, okay? And so it's actually fewer numbers that you're going to have, because that one group of 3 cannot be changed multiple ways to have different groups. It's just that one group. And so your combinations are actually going to be smaller than if you did a permutation of the same thing. And what you'll notice is your denominator has an extra number in it, which is going to make it smaller, right? So you do the total factorial over the same number, and then you also have the group number at the bottom as well. So this adds something else at the bottom when you do a combination. If you look at the first example, there are 7 seniors, 5 juniors, and 4 sophomores on the PEP squad. Mr. Reinhardt needs to choose 12 students out of the group to sell spirit buttons during lunch. How many ways can the students be chosen? This order does not matter. The order in which those 12 people are chosen does not matter for this. It's just a group of people doing something. All right, and so for this is going to be a combination. So as you look at these examples, you're really just trying to decide, is this a permutation or a combination? The calculation of it is not hard. All right, and so for this, how many do we have all together?
16.
All right, yeah, I have 16 kids all together. My group is 12, so I am going to do a combination. So if I did it out, it would look like this. All right, and when you do it in your calculator, it's actually not an approximation. I did 16 minus 12, that's 4, and then I did my R again, which is 12 factorial. And that's 1,820 ways. If you did a permutation, it would be bigger. You would have more ways than that. So there are 1,820 ways 12 students can be chosen from this particular group. All right, look at the next example. If the students are randomly chosen, what is the probability that 4 seniors, 4 juniors, and 4 sophomores will be chosen? All right, 4 juniors, 4 seniors, and 4 sophomores. All right, so now I am going to do just those individually and multiply it. I'm going to do those. I want 4 seniors. How many different ways then can I choose 4 seniors? Well, I look at my total pool of seniors. How many seniors do I have? I have 7. So this one is going to be a combination of 7 things, and I want 4 of them. I am going to multiply that by my next option. I want 4 juniors. How many juniors do I have?
4.
I have 5, so I want 5 things taken 4 at a time. All right, and then I also want 4 sophomores. How many sophomores do I have?
4.
I have 4. All right. And so when I multiply those out, you are going to find that I have 175. It wasn't just asking how many ways. It said, what's the probability of getting that number? All right. So that's my counting of that, but that's what I want over the total possible, which was 1820. So my probability here is going to be 5 out of 52. Right? Which is a little less than 10%. All right, little less than 10% probability that will happen. All right, so when you check this, you should have gotten 15,504. 15,000.